Good morning, students. Am I audible?
Write
in the chat box. Am I audible? Okay, let's start. Today we'll discuss about irrational functions. A polynomial function or a rational polynomial function a polynomial function or a rational polynomial function raised to a rational power is called an irrational function. A polynomial function or a rational polynomial function raised to a rational power is called an irrational function. That is, y is equal to f of x equal to p of x raised to the power 1 by n, or y is equal to f of x equals to p of x upon q of x raised to the power 1 by n. Okay. Or y is equal to, for particular example, f of x is equal to under root x minus 1 is an irrational function. F of x is equal to under root 2x plus 3 upon 3x minus 1 is an irrational function, or f of x is equal to under root x square minus 5x plus 6. This is an irrational function. Okay. These are the examples of irrational function. Now come to find the domain of irrational function. Domain of irrational function. First of all, we'll take the irrational function type 1. Y is equal to f of x is equal to p of x raised to the power 1 by n. Then domain F is the set of all x such that p of x greater or equal to 0 if n is even or if n is odd. since we are dealing with real valued functions, if p of x takes negative value and n is even, the even root of a negative number is an imaginary number. Okay, neither the input nor the output can be an imaginary number. If a function gives imaginary value for some x, then we can say that the function is undefined at that point. So function to be defined, if n is even, function to be defined if p of x should be greater or equal to 0. Otherwise, imaginary value will come. If n is odd, then p of x can take any real value. It is positive or negative, whatever. So if n is odd, the domain of the function is R. Suppose the function is f of x is equal to under root x minus 1. Function to be defined, expression within under root should be greater or equal to 0. We can write domain f is equal to, because it is even root, square root. So a set of all x are that x minus 1 should be greater or equal to 0. X minus 1 greater or equal to 0 implies x is greater or equal to 1. This implies x belongs to 1 to infinity, right? Then come to second case. If y is equal to f of x, p of x upon q of x raised to the power 1 by n, y is equal to f of x is equal to p of x upon q of x raised to the power 1 by n, then domain of the function is equal to, domain f is equal to set of all x such that p of x upon q of x greater or equal to 0, provided if n is even, r, second case, r minus q of x is equal to 0 if n is odd. Clear? The under root expression, even root, if n is even, then the under root expression should be positive. Otherwise you will get imaginary value. Right? Is it clear? Write in the chat box. Is it clear? To find the domain of irrational functions, we should know how to solve inequations or inequalities. Okay. Gayatri, Simran, we should know how to solve an inequality. So write down solution of inequations. Solution of inequations. First come to solve that. First write down the number line, then interval, then solution. Zero, 1, 2, 3 up to infinity, -1, -2, -3 up to minus infinity. This is your number line. Then write down interval. Write down an interval is a subset of, an interval is a subset of real numbers. An interval is a subset of real numbers. An interval is a subset of real numbers. Intervals are of three types: open interval, closed interval, semi-open or semi-closed interval. First come to know what is open interval. Let A and B be two real numbers. such that A less than B. Let A and B be two real numbers such that A less than B. Open interval of A and B. Open interval of A and B is written as like this, AB. Open interval is like this, which is defined as, quickly note it, I will use next page. Which is defined as open interval AB is the set of all x such that A less than x less than B. That means open interval of A and B represent the set of all real numbers, those who lie between A and B, but A and B are not included. So take the number line, A is less than B, A, mark a point as A, another point as B. Okay, all the real numbers between A and B, excluding A and B. So put hollow circles above A and B. If a hollow circle is above A, then it represents A is not included, A is excluded. So set of all real numbers, those who lie between A and B, but not including A and B. Then come to closed interval. Closed interval of A and B is denoted by this square bracket, which is defined as set of all x such that A less or equal to x less or equal to B. All the real numbers between A and B, including A and B. So A, B, put field circles over A and B. Field circle represents the number is included. Okay. Open circle or hollow circle represents the number is not included. Then semi-open or semi-closed. Semi-open or semi-closed. Semi-open or semi-closed interval. A closed, B open. A closed, B open is the set of all real x such that x, so A less or equal to x, A is included, B is excluded. Okay. Take the number line, mark the points as A and B. A included means a field circle will be over A, B excluded, hollow circle above B. Okay, similarly, A open, B closed. A open, B closed is the set of all x such that A less than x less or equal to B, A excluded, B included. Put hollow circle over A and field circle over B. O, A open, B closed. Okay. I hope it is clear to you. Is it clear? Write in the chat box. Interval clear? Then come to solution of inequations. First come to linear inequation in one variable. Linear inequation in one variable. The linear equation in 1 is ax plus b is equal to 0. Linear inequation is ax plus b greater than 0, or ax plus b less than 0, or ax plus b greater equal to 0, or ax plus b less equal to 0. Ax plus b greater than 0, ax plus b less than 0, ax plus b greater equal to 0, ax plus b less equal to 0. So ax plus b equal to 0. To solve this equation, what is the next step? The next step is ax is equal to minus b. Okay, there is no such mathematical operation that quantity will be shifted to right hand side. What we are doing here, we are adding negative b to both sides of the equation. We are adding negative b to both sides of the equation. So keep in mind, if a constant quantity is added to both sides of an inequation remains unchanged. Okay. Suppose the inequation, just a minute. Suppose the inequation is ax plus b greater than 0. To solve this inequation, now the next step is to add a negative b to both sides of the inequality. Ax plus b minus b greater than 0 minus b. So ax is greater than minus b. So if a constant quantity is either added to or subtracted from both sides of an inequality, then inequality symbol of the inequality remains unchanged. This is the first step. Second, how to solve this? The next step is x is equal to minus b by a. That means we have to divide both sides of the equality by a. But in case of inequality, there is a little bit different. If we are dividing or multiplying both sides of an inequality by same positive constant quantity, then symbol of the inequality remains unchanged. But if we divide or multiply both sides of an inequality by a negative constant quantity, then symbol of the inequality will be reversed. Take the example, you see 3 is greater than 2. If we multiply 2 both sides, then 6 is greater than 4. But if we multiply both sides of the inequality by negative 2, then it will be minus 6 less than minus 4. Okay? Minus 6 less than minus 4. So, to solve the inequality ax plus b greater than 0, the next step is ax greater than minus b. Now we have to get the value of x. We have to divide both sides by a. Before dividing both sides by a, we have to notice what is the sign of a. If a is positive, then we have to consider two cases here. Case 1, a is a positive constant quantity. If a greater than 0, then directly you can write x is greater than minus b by a. Okay. And if you want to put the solution in the number line, take the number line, mark a point as minus b by a. Greater than minus b by a means right hand side of minus b by a. It is minus b by a to infinity. The solution is minus b by a to infinity. Then second scenario, that second case, a is less than 0. That means a is a negative quantity. If a is a negative quantity, if we divide both sides of this inequality by a, then symbol will be reversed. In place of greater than, it will be less than. So ax greater than minus b, ax greater than minus b implies x less than minus b by a. So solution is x belongs to minus infinity to minus b by a. I hope it is clear. Is it clear to you? Write in the chat box. Is it clear? Gayatri, Susri Simran, Subhranshu. Okay, Biswajit. So let's come to solve a couple of questions on linear inequality. Suppose the question is, solve 2x minus 3 greater equal to 0. Solve 2x minus 3 greater equal to 0. So the next step is 2x is greater equal to 3. x is greater equal, here 2 is positive, so directly we can divide. X is greater equal to 3 by 2. Take the number line, mark a point as 3 by 2. Either equal to 3 by 2 or greater than 3 by 2, that 3 by 2 is included. We should put a field circle over 3 by 2, then 3 by 2 to infinity. So x belongs to, the answer in interval form is x belongs to 3 by 2 to infinity. Okay. Now you solve the following. Okay, solve these questions. Send me the answer to chat box. 3 by 2 to infinity, Gayatri. 3 by 2 closed. Oh, sure. Okay. Previous one. Modulus function. Minus infinity to 1 by 3, minus infinity to 1, Arpita Bharati, Gayatri. Yes, minus infinity to 1 by 3 is correct. Minus infinity to 1 is also correct. Good. Hmm. Oh. Hmm? Wait, okay. ଏଇଗୋଟା ଅପସନ୍ ଦରକାର ଗୋଲମରିଚ କରିଛି For more complete Gayatri. Okay. Okay, let's come to the solve. The first one. The first one is 3x minus 1 less than 0. 3x minus 1 less than 0. This implies 3x less than 1. This implies x less than 1 by 3. So x belongs to minus infinity to 1 by 3. This is the solution to the first question. Okay, let's come to the second one. Second one is 2 minus 3x greater equal to 4x minus 5. So taking all x into one side, 2 plus 5 is greater equal to 4x plus 3x, or you can say 7x is less than 7. 7x less or equal to 7. This implies x less or equal to 1. So x belongs to negative infinity to 1 closed. Then come to third one. The third question is 4x minus 1. 4x minus 1 is less or equal to 2x plus 3. 4x minus 1 is less or equal to 2x plus 3. This implies 4x minus 2x is 2x less or equal to 1 plus 3, that is 4. 2x less or equal to 4 implies x less or equal to 2. Okay, so solution is x belongs to negative infinity to 2 closed. Then come to the fourth one. 4 upon x minus 2 is greater or equal to 0. You see, this is a rational expression where the denominator is a non-zero quantity. So this rational expression can never be equal to 0. A rational expression will be equal to 0 only when the numerator is 0. Here the numerator is 4, which is a non-zero quantity. So the only possibility is this expression can be greater than 0. You know, a by b is greater than 0 when both a and b are of same sign. Here 4 is positive. The total expression will be positive when x minus 2 is positive. This implies x greater than 2. So x belongs to open interval 2 to infinity. I hope it is clear to you. Did you understand, guys? Write in the chat box. Is it clear? Okay. Then come to quadratic inequality or quadratic inequations. Quadratic inequality or quadratic inequations. Quadratic inequality or quadratic inequations. What is the format of quadratic inequation? The format of quadratic inequation is ax square plus bx plus c greater than 0 or ax square plus bx plus c less than 0 or ax square plus bx plus c greater or equal to 0 or ax square plus bx plus c less or equal to 0. Okay, these are the forms of quadratic inequality. So there is a method known as the working rule to solve quadratic inequality. Write down working rule or stepwise approach how to solve a quadratic inequality. Working rule. Solution of quadratic inequality when the discriminant d is greater than 0. What is d? D is equal to b square minus 4ac. All of you know what is d in quadratic equation. B square minus 4ac. This working rule is the case where d is greater than 0. So step 1. Okay. Gayatri, you are from which higher secondary? Oh, Gayatri, you are from BJP higher secondary. Okay. So step 1. Factorize the quadratic expression in the inequality factorize the quadratic expression in the inequality into linear factors or by finding the roots. Okay, this is your step 1. To solve the inequality, first of all, we have to factorize the quadratic expression in the inequality into linear factors, either by middle term splitting or by finding the roots. Into linear factors by finding roots or by middle term splitting, whichever is suitable for you. This is your step 1. Okay. Then step 2 is make the coefficient of x positive. Make the coefficient of x positive in both the linear terms make the coefficient of x positive in both the linear terms if they are not so. Okay, this is your step 2. Then come to step 3. Step 3 is equate each of the linear term to 0. Equate each of the linear term to 0 and get the values of x. In bracket, these values are roots or critical points. These values are roots or critical points. Then come to step 4. Mark the critical points on the number line according their order relation. Order relation means smaller number will be in the left hand side and larger number will be in the right hand side. And these two critical points divide the number line into three regions. the two critical points divide the number line into three regions. This is your step 4. Quickly note it down. I will use the next page. 2 more steps are left. Done. Then step 5. Okay. The step 5 is mark the regions positive and negative. Mark the regions positive and negative, starting with a positive sign. Mark the regions positive and negative, starting with a positive sign from right hand side. Then pick up the region required. Okay. Let me solve a couple of questions so that you can understand the steps. So write down a question, solve. X square minus 5x plus 6 greater or equal to 0. Okay. Here d is greater than 0. D is equal to b square minus 4ac, that is 25 minus 24, which is equal to 1, which is greater than 0. So what is your first step? The first step is to factorize the quadratic expression and the inequality into linear factors, either by middle term splitting or by finding the roots. Okay. This is a common quadratic expression. You know, this can be factorized as x minus 2 into x minus 3. X minus 2 into x minus 3 is greater or equal to 0, right? Clear? Now, what is your next step? The next step is make the coefficient of x positive in each of the linear terms. Here, two linear terms are there. One is x minus 2, other is x minus 3. In both the linear terms, the coefficient of x is 1, which is positive. So, no need to make them positive. They are positive already. Okay. Now, we have to, step 3 is equate each of the linear term to 0. That means we have to equate x minus 2 with 0 and x minus 3 to 0. If we equate x minus 2 0, the value of x will be 2. If we equate x minus 3 is equal to 0, the value of x is 3. These are called roots or critical points. What is the next step? The next step is we have to mark the critical points on the number line. According to that order relation, 2 is less than 3. So 2, 3. Okay. These two critical points divide the number line into 3 regions. What are the regions? The left hand side region is minus infinity to 2. The middle region is 2 to 3. And the right hand side region is 3 to infinity. Okay. Then put the signs positive and negative alternately. Start positive and negative alternately. Mark the regions positive and negative alternately. Positive, negative, positive, starting with a positive sign from right hand side. Okay. Then pick up the region required. Which region is required? Greater or equal to 0. Equal to 0, the expression will be equal to 0 at x is equal to 2 and x is equal to 3. So 2 and 3 will be included. Hence, we have to put filled circles over 2 and 3. So 3 to infinity, the region where expression is positive, and minus infinity to 2 is the region where expression is positive. Hence our answer is x belongs to minus infinity to 2 closed, union 3 closed, infinity open. Union 3 closed, infinity open. Did you understand? Hello? Did you understand, guys? Yes, right. It is Obikar method. Just a minute. Okay, come to another example. Suppose solve x minus 1 into 4 minus x greater or equal to 0. Solve x minus 1 into 4 minus x greater or equal to 0. Okay. Here, the quadratic expression is already in factorized form. Here is a linear factor, that is x minus 1. Another linear factor is 4 minus x. In the linear factor 4 minus x, the coefficient of x is positive. Clear? So to solve inequality, we have to make the coefficient of x positive. How we can make it positive? By multiplying -1. You should keep in mind, when you multiply negative quantity to both sides or -1 to both sides, the symbol will be reversed. So the next step will be x minus 1 into 4 minus x. Sorry, x minus 4. Sorry. X minus 1 into 4 minus x minus 4. It will be less or equal to 0. Okay. Now equate this one with 0, this one with 0. The critical points are 1 and 4. 1 and 4 plus minus plus. Which region is required? Negative or 0? It will be 0 at the critical points. So critical points will be included. Field circles will be taken over 1 and 4. Then 1 to 4. Answer is 1 to 4 closed interval. Answer is 1 to 4 closed interval. Okay. 1 to 4. Yes, Simran, you are correct. So what is the moral of the story? The moral of the story is, first of all, you have to check whether the coefficient of x square is positive or negative. If a quadratic inequality is there, first of all, you have to find d, that is b square minus 4ac. Then you have to check the coefficient of x square, which is otherwise known as leading coefficient. If the coefficient of x square is negative, if you factorize it into linear factors, then in one of the linear factors, coefficient x will be negative. Then you have to multiply -1 to make it positive. So it is better to first make the coefficient of x square positive. Okay, if a quadratic expression is given or inequality is given where the coefficient of x square is negative, then make it positive on multiplying -1 to both sides. And keeping in mind, when you are multiplying -1 to both sides, the symbol will be reversed. Second thing, directly find the roots. Okay, either by middle term splitting or by solving the equations. Write down a note point. If alpha and beta are roots of the equation, if alpha and beta are roots of the equation, ax square plus bx plus c is equal to 0. If alpha and beta are roots of the equation ax square plus bx plus c is equal to 0, then by factor theorem, ax square plus bx plus c can be factorized as a times x minus alpha into x minus beta. Okay. So the moral of the story is, if the coefficient of x square is negative, then make it positive by multiplying -1. Then find the roots. If roots are alpha, beta, put the number line, mark alpha and beta. Suppose alpha is less than beta, alpha will be in the left hand side and beta will be in the right hand side. Then check whether greater than region is there. or less than region is there, or greater equal to, less or equal to. If equality symbol is there, then critical points will be included. If equality symbol is not there, then critical points will be excluded, right? If greater than 0 is there, then you have to take the extreme regions. Extreme regions means this region and this region. If less than 0 is there, then you have to take the mean region, that is the middle region. Okay. So if you follow these steps, so directly in one step you can write the answer. I hope it is clear to you. Should I give some question to you so that you can solve? Gayatri? Okay. So guys, try to attend these classes on a regular basis so you'll be benefited. Okay. High level content will be delivered. Okay, solve the following. X square minus 3x minus 1 less than 0, 2x square plus 5x minus 3 greater or equal to 0, x square minus 4x minus 3 less or equal to 0. These are the three questions. Okay, solve it, then we'll go for rational inequality, then inequality of a higher degree. One, two, four. Send me the answer. X square minus 3x minus 1 less than 0, right? So now solve x square minus 3x minus 1 is equal to 0. Ax square plus bx plus c is equal to 0 implies x is equal to minus b plus or minus under root b square minus 4ac by 2a. So x is equal to minus b, that is 3, plus or minus b square is 9, 4ac is 4, divided by 2a is 2. This is equal to 3, plus or minus root 13 by 2. So the critical point, one of the critical point is 3 minus root 13 by 2, and other critical point is 3 plus root 13 by 2. 3 minus root 13 by 2, then 3 plus root 13 by 2. Regions are plus, minus, plus. Negative region is required. So x belongs to 3 minus, so no, open interval. 3 minus root 13 by 2 to 3 plus root 13 by 2. This is the answer to your first question, right? Let me check the, these are more complete. 3 minus root 13 by 2 to 3 plus root 13 by 2, Gayatri. Okay, good, good. I think Gayatri is a JEE aspirant. Gayatri, what is your aspiration? You are preparing for JEE or NEET? NEET. Acha. Then come to the question. This is the solution to question number 1. Then come to solve the question number 2. The question number 2 is 2x square plus 5x minus 3 greater or equal to 0. Now solve the equation and get the critical values. 2x square plus 5x minus 3 equal to 0. This implies x is equal to minus b, that is minus 5 plus or minus under root b square minus 4ac. B square is 25 minus 4ac is 24 divided by 2. Or middle term is also possible. So minus 5 plus or minus 7 upon 2, which is equal to minus 6 and 1. Okay. So critical points are minus 6 and 1. To take the critical point, minus 6, 1, plus, minus, plus. Positive region is required along with 0 region. That is, critical points will be included. So x belongs to negative infinity to negative 6 closed union 1 to infinity. Let me check the answer of Gayatri. Gayatri, your second question answer is incorrect. Minus infinity to minus 3 union 1 by 2 to infinity. No, it is minus infinity to minus 6 union 1 to infinity. Okay. Then come to third one. Third question. Square minus 4x minus 3 less or equal to 0. X square minus 4x minus 3 less or equal to 0. So x is equal to minus b, that is 4, plus or minus under root b square 16 plus 12 divided by 2 is 2, 4 plus or minus 2 root 7 upon 2. This is equal to 2 plus or minus root 7. So critical points are 2 minus root 7 and 2 plus root 7. 2 minus root 7 and 2 plus root 7. Apply the sign scheme, plus minus plus. Negative region is required along with 0. So solution is x belongs to 2 minus root 7 to 2 plus root 7. This is the answer to the third question. Let me check the answer of, how come it is 1, 2, 3? Gayatri, rectify your mistakes. That means x minus 1 into x minus 3. X minus 1 into x minus 3, then it will be plus 3. Rectify. It is not x square minus 4x plus 3. It is x square minus 4x minus 3, I think. Yes, x square minus 4x minus 3. Okay. Done. So quadratic inequality is over. Now we'll go for rational inequality. The same inequality will be followed while solving a rational inequality. The steps those who are following to solve quadratic inequality, same steps will be followed to solve quadratic inequality. Rational inequality. Okay. Should I go to next page? Guys, tell me, is it clear to you? Write in the chat box. Avinash, Vishwajit, Anusha. Is it clear? JKBK, Nandini. Okay. Then come to solve rational inequality. You see, A into B and A upon B. A into B and A upon B. The sign scheme for A into B and A upon B are same. If both A and B are positive, then A into B is positive, A by B is positive. If both A and B are negative, then A into B is positive, A by B is positive. Suppose A positive, B negative. AB will be negative, A by B will be negative. Suppose A negative, B positive. AB will be negative and A by B will be negative. This is the scenario, right? So, A into B greater than 0 is equivalent with A by B greater than 0. Suppose the inequality is x minus 2 into x minus 3 greater than 0. X minus 2 into x minus 3 greater than 0. This is equivalent to which x minus 2 upon x minus 3 is greater than 0, isn't it? So to solve a rational inequality, the same working rule, those we are using for solving quadratic inequality should be followed. Okay. Second question, 2x minus 1 into x plus 3. Okay, let me check again. No. Let me factorize it again. So 2x square plus 5x minus 3. So 2x square plus 2x plus 3x. Sorry. Oh, plus 6x minus x. Okay. X plus 3. 2x into x plus 3 minus 1 into x plus 3. 2x minus 1 into x plus 3. Oh, I have done a mistake. I have done. This is 4, not 2. This is 4. Okay, you are correct, Gayatri. You are correct. This is 4, not 2. Okay. Let's move forward. So x minus 2 into x minus 3 greater than 0. If the question is solve x minus 2 upon x minus 3 greater than 0, we should follow the same steps. Equate the linear term to 0. The critical values are 2 and 3. So mark the critical values on the number line. Apply the sign scheme plus minus plus. Positive region is required. That means extreme region should be taken and critical points are not included. So we can write the answer as x belongs to minus infinity to 2 union 3 to infinity, right? X belongs to minus infinity to 2 union 3 to infinity. But there is a difference. What is the difference? Suppose a by b greater equal to 0 and a into b greater equal to 0. Okay. If a by b equal to 0, this is possible only when the numerator is equal to 0. If a into b is equal to 0, this is possible either when a is equal to 0 or b is equal to 0. If the inequality is like this, suppose, take the example, solve x minus 2 upon x minus 3, solve x minus 2 upon x minus 3 greater equal to 0. Solve x minus 2 upon x minus 2 greater equal to 0. First find the critical points. Critical points are 2 and 3. So mark the critical points on the number line. 2, 3, plus minus plus. You see, it will be equal to 0 only when the numerator is equal to 0. So critical point of the numerator, if equality symbol is there in a rational inequality, the critical points, those who belong to the numerator should be included and critical points of the denominator should be excluded. So minus infinity to 2 closed, 3 to infinity. So solution is x belongs to minus infinity to 2 closed union 3 to infinity. I hope it is clear to you. Okay, guys, write in the chat box. Is it clear? Come to next question. Solve x square minus 5x plus 6 upon 2x minus 1 is greater than 0. Solve x square minus 5x plus 6 upon 2x minus 1 greater than 0. So come to the solution. Factorize the quadratic expression in the numerator. It will be factorized as x minus 2 into x minus 3, x minus 2 into x minus 3 upon 2x minus 1 greater than 0. What are the critical points? If we equate the Denominator to 0, it will be 1 by 2. This will give you 2, this will give you 3. So the critical points are 1 by 2, 2, 3. And then apply the sign scheme plus, minus, plus, minus. Which region is required? Greater than 0 region. 1 by 2 to 2, union 3 to infinity. So x belongs to 1 by 2 to 2, union 3 to infinity. Okay. Is it clear? Write in the chat box, is it clear? Okay. Now you try to solve a couple of questions. Solve the following. Okay, these are the 3 questions. Try to solve. One to 2 union 4 to infinity. All the critical points are included. Gayatri, 4 should not be included because 4 is in the denominator. If you include 4, then the denominator will be 0. If in a rational expression, denominator is 0, then it is undefined. So you should put open symbol before 4. Quickly solve it. It is 1 to infinity. Yes, 1 to infinity. Correct. 1 to infinity is correct. Oh. Okay, let's start solving. Solution. Come to the first one, x square minus 3x plus 2 upon x minus 4 is greater or equal to 0. This implies x minus 1 into x minus 2 upon x minus 4 is greater or equal to 0. Okay. Okay, guys, let me check. The critical points are 1, 2, 4. 1, 2, 4. So plus, minus, positive region 1 to 2, union 4 to infinity. The answer to the first one is x belongs to 1 to 2, union 4 to infinity, right? Then come to question number 2. The question number 2 is 2x plus 1 upon x minus 1 is greater or equal to 2. Okay. While solving this type of inequality, some students commit some simple mistakes. They multiply the denominator to both sides. They cross multiply the expression, but it is not allowed. While you are solving inequality, it is not allowed to cross multiply the terms because you don't know whether the denominator is a positive expression or a negative expression. If the denominator is a positive expression, then directly you can multiply. Otherwise, you have to bring down the constant quantity to the left hand side and solve it. Okay. So this is implies 2x plus 1 upon x minus 1 minus 2 is greater or equal to 0. So 2x plus 1 minus 2x plus 2 upon x minus 1 is greater or equal to 0. Plus 2x minus 2x cancels. Finally, the expression is 3 upon x minus 1 greater or equal to 0. So the numerator is a constant quantity and it is positive. So this expression can never be equal to 0. The only possibility is this expression can be greater than 0, which is possible only when x minus 1 is greater than 0. So x is greater than 1. So x belongs to 1 to infinity, right? This is the answer to question number 2. Then come to question number 3. Quickly note it down. I will erase this part. I will erase, create space. Then come to solve the third one. 4x plus 1 upon x minus 2 less or equal to x plus 1 upon x plus 3. 4x plus 1 upon x minus 2 less or equal to x plus 1 upon x plus 3. We can't cross multiply the terms, so we have to bring the expression x plus 1 upon x plus 3 to left hand side. Right? Then take the LCM. 4x plus 1 into x plus 3 minus x plus 1 into x minus 2 less or equal to 0. This implies 4x square plus 12x plus x plus 3 minus x square minus 2x plus x minus 2 upon x minus 2 into x plus 3 less or equal to 0. Right? So 4x square minus x square is 3x square. 12x plus x is 13x. 13x plus 2x 15x minus x 14x. 3x square plus 14x. Then here the constant quantity 3 plus 2 is 5 upon x minus 2 into x plus 3 is less or equal to 0. So this implies 3x square plus 15x. So better to find the root. So this is equal to 0. 3x square plus 14x plus 5 is equal to 0. So x is equal to minus 14 plus or minus 14 square 196 minus 4s minus 60 upon 2h 6. So minus 14 plus or minus under root 136 divided by 6. Okay. So this is equal to 136 by 4. 34 minus 14 plus or minus 2 root 34 divided by 6. This is equal to minus 7 plus or minus root 34 divided by 3. Okay. So critical point minus 3 minus 7 minus root 34 will be less than minus 3. Okay. Minus 7 minus root 34 upon 3 then minus 3 minus 7 plus root 34. Minus 7 plus root 34. Minus 7 plus root 34 upon 3. Then next critical point is 2 plus minus plus negative region. The critical point to the numerator will be included. This one included. This is excluded. This is included. And this is excluded. Okay, this is the answer. Hope it is clear to you. Gayatri. How come it is possible? 3x into 5, it will be 15x minus x, it will be 14x. So this is 3x minus 1 into x plus 5. If you take from these two terms, 3x square plus 15x, 3x minus from these two terms, 3x square plus 15x, you can take 3x as common. So 14x minus x. It is not minus 5, it is plus 5 here. It is plus 5, not minus 5. Okay. Gayatri, it is not minus 5. Okay, this is the answer. So guys, your first session is over. That is from 7:30 to 9. The next session is from 9:15 to 10:30. It will be very amazing one. Okay. I'll solve good questions from JEE point of view. So now you go and have your breakfast, then join exactly at 9:15. कटक जेकेबीके शुभ्रांशु शेखर धीर हायर सेकेंडरी कटक मधुस्मिता नंदिनी रामजी हायर सेकेंडरी भीष्मगिरी Muthu Subhanshu Shekhar Dhir. Okay, so guys, start the session. To come to solve inequation of a higher degree. Inequation of higher degree, right? Suppose question is solve x cube minus 6x square plus 11x minus 6 greater or equal to 0. X cube minus 6x square plus 11x minus 6 greater or equal to 0. Now you can factorize this expression as x minus 1 into x minus 2 into x minus 3 greater or equal to 0. Okay, what is the next step? Equate each of the linear term to 0. This one to 0, this one to 0, this one to 0. So critical points are 1, 2, 3. Mark the critical points on the number line. Then take the regions, mark the region positive, negative. To take the region required 1 to 2. 0 is also included, so critical points will be included. So the solution is x belongs to 1 to 2 union 3 to infinity. 1 to 2 union 3 to infinity. Right? I hope it is clear to you. Did you understand JKVK, Madhusmita, Amrita? Okay, try to solve these two questions. Solve these two questions and send me the answer. x cube minus x less than 0. This implies x into x square minus 1 less than 0. This implies x into x plus 1 into x minus less than 0. The critical points are minus 1, 0, 1, plus minus, plus minus. Negative region is required. So minus infinity to minus 1, union 0 to 1. Solution is minus infinity to minus 1, union 0 to 1. This is the answer to question number 1. Then come to question number 2. Question number 2 is x to the power 4 minus 13x square plus 36 greater or equal to 0. This implies x square minus 9 into x square minus 4 greater or equal to 0. This implies x plus 3 into x minus 3 whole into x plus 2 into x minus 2 greater or equal to 0. What are the critical points? The critical points are minus 3, minus 2, 2 and 3, plus minus, plus minus, plus. So positive region, minus infinity to minus 3, minus 2 to 2, then 3 to infinity. So x belongs to minus infinity to minus 3, union minus 2 to 2, union 3 to infinity. Clear? Okay. So now we will be able to find the domain of irrational functions. Question, find the domain of the following functions. Find the domain of the following functions. F of x is equal to under root x square plus 2x minus 1. F of x is equal to under root x cube minus x. F of x is equal to under root 9 minus x square. F of x is equal to under root x to the power 12 minus x to the power 9 plus x to the power 4 minus x plus 1. Okay. Find the domain of the following functions. f of x is equal to under root x square plus 2x minus 1. F of x is equal to under root x cube minus x. F of x is equal to under root 9 minus x square. And f of x is equal to under root x to the power 12 minus x to the power 9 plus x minus x plus 1. Come to the solution. F of x is equal to under root x square plus 2x minus 1. So domain is this expression within the even root should be greater or equal to 0. Otherwise, because even root of a negative quantity is imaginary quantity, since we are dealing with real valued functions, the function is defined when the under root expression is greater or equal to 0. So domain of the function is set of all x such that x square plus 2x minus 1 greater or equal to 0, right? So come to the solution. X square plus 2x minus 1 greater or equal to 0. Now find the roots. The roots are minus 2 plus or minus b square, that is 4, minus 4h, that is 4, upon 2h is 2. So minus 2 plus or minus 2 root 2 upon 2. This is equal to minus 1 plus or minus root 2. So the critical points are minus 1 minus root 2 and minus 1 plus root 2, minus 1 minus root 2 and minus 1 plus root 2. So regions are plus, minus, plus. Positive region is required. So x belongs to minus infinity to minus 1 minus root 2, minus 1 plus root 2 to infinity. So domain of the function, domain f is equal to minus infinity to minus 1 minus root 2 union minus 1 plus root 2 to infinity. Yes. Come to the question number 2. F of x is equal to square root of x cube minus x. F of x is equal to square root of x cube minus x. So domain of the function is the set of values of x for which the function is defined. The expression x cube minus x is under even root. The function to be defined, expression under even root should be greater or equal to 0. So set of all x such that x cube minus x greater or equal to 0. X cube minus x greater or equal to 0. So x times x square minus 1 greater or equal to 0. Then this can be factorized as x into x minus 1 into x plus 1 greater or equal to 0. The critical points are minus 1, 0 and 1. So plus minus, positive region is required, minus 1 to 0, union 1 to infinity. Thus domain F is equal to minus 1 to 0, union 1 to infinity. Okay, this is the answer to question number 2. So guys, quickly note it down. I'll go to the next question. Done. Is it clear? Write down the chat, write in the chat box. Is it clear to you? Then come to question number 3. F of x is equal to under root 9 minus x square. F of x is equal to under root 9 minus x square. The function to be defined or domain of the function is equal to set of all x such that 9 minus x square is greater or equal to 0. Okay. 9 minus x square is greater or equal to 0 implies x square minus 9 less or equal to 0. This implies x plus 3 into x minus 3 less or equal to 0. The critical points are minus 3 and 3, plus minus plus, negative region. So minus 3 to 3, and so domain of the function is minus 3 to 3. Domain of the function is minus 3 to 3. Is it clear? Write in the chat box. Okay, come to the last question. F of x is equal to under root x to the power 12 minus x to the power 9 plus x to the power 4 minus x plus 1. So domain of the function is equal to set of all x such that x to the power 9, sorry, x to the power 12 minus x to the power 9 plus x to the power 4 minus x plus 1 greater or equal to 0. Now solve the inequality. X to the power 12 minus x to the power 9 plus x to the power 4 x to the power 12 minus x to the power 9 plus x to the power 4 minus x plus 1 greater or equal to 0. Now from these two terms we can take x to the power 4 as common. From these two terms we can take x as common or minus x as common. So x to the power 12 plus x to the power 4 minus x to the power 9 minus x greater or equal to 0. So if you take x to the power 4 as common from the first two terms, it will be x to the power 4 times x to the power 8 plus 1. Now you can take minus x as common from the next two terms. It will be minus x times x to the power 8 plus 1 greater or equal to 0. Now again we can take x to the power 8 plus 1 as common. This implies x to the power 8 plus 1 into x to the power 4 minus x plus 1 greater equal to 0. Finally, the expression is x to the power 8 plus 1 into x to the power 4 minus x plus 1 greater equal to 0. Okay, take the number line. So you see, this is always positive. X to the power 4 is positive. 1 is positive. So when x is negative, then minus x will be positive. This expression is positive for all real values. This expression is positive for all real values. This expression is positive for all real values. The expression negative x is positive when x is less than 0. So when x is less than 0, total expression is positive. When x is less than 0, total expression is positive. Okay. So the expression x to the power 12 minus x to the power 9 plus x to the power 4 minus x plus 1 is positive when x is a negative real number. Okay, again, when x is very, very small, higher power of x will give you the lower value. When x is greater than 1, higher power of x is greater than lower power of x. If x belongs to 1 to infinity, x to the power n is greater than x to the power n if m is greater than n. Okay. So when x belongs to 1 to infinity, x to the power 4 is greater than x. So x to the power 4 minus x is positive. This is always positive. 1 is also always positive. So in the region 1 to infinity also, the expression is positive. The only region left over is 0 to 1. Now we have to check whether the interval 0 to 1, the expression is positive or negative. Okay. So to find the sign scheme for the expression in the interval 0 to 1, we have to rearrange the expression this. Okay. X to the power 12 minus x to the power 9 plus x to the power 4 minus x plus 1 can be written as x to the power 12 plus x to the power 4 minus x to the power 9 plus of 1 minus x. Right? When x belongs to the interval 0 to 1, higher power of x will give you the lower value. So x to the power 4 is greater than x to the power 9. X to the power 4 minus x to the power 9 is positive. X belongs to 0 to 1 means 1 minus x is positive, and x to the power 12 is always positive. So in the interval 0 to 1 also, the expression is positive. Okay. And 0 when expression clear. So the expression x to the power 12 is greater or equal to 0 only when x belongs to R. So we can say domain of the function is R. I hope it is clear to you. Domain of the function is R. Clear? Then come to find the range of the following functions. Okay, try to find the range of these following 4 questions. For function, find the range of these functions. Come to question number 1. F of x is equal to under root x minus 1. Okay. The expression x minus 1 or the function x minus. This is a composite function, function of a function. Okay. The inside function x minus 1 is a strictly increasing function. Y is equal to x minus 1 is a straight line. Okay. With x intercept 1 and y intercept minus 1. This is like this. So when the expression gives you positive value, then the function will be defined. So positive value from 0 to infinity. From 0 to infinity when x minus 1 greater or equal to 0, when x greater or equal to 1, the function is defined. When x is greater or equal to 1, the expression x minus 1 gives you the value. The x minus 1, x is greater or equal to 1, x minus 1 belongs to 1 to infinity, right? And the square root of 1 to infinity will be 1 to infinity. What is range? The range of a function is the set of obtained values of a function or set of functional values of a function. Okay. So the input, the inside expression x minus 1 gives you the value 1 to infinity. If you take the root over of 1 to infinity, again it will give it 1 to infinity. So range of the function is 1 to infinity. Is it clear to you? Did you understand, guys? Let me know through the chat box. Is it clear? Amrita? Vibhu Prasad, is it clear? JKVK? Write in the chat box, is it clear? Nandini? Class should be interactive. Otherwise, I will know whether you understand or you didn't understand. Okay. Then come to the next question. F of x is equal to under root 9 minus x square. F of x is equal to under root 9 minus x square. Right? How to find the range of the function f of x is equal to under root 9 minus x square. you see the inside expression. The inside function is 9 minus x square. 9 minus x square is nothing a downward directed parabola. This is the graph of 9 minus x square. This is 0, 9. I'm taking the graph of 9 minus x square, not the graph of root over of 9 minus x square. Okay. And in the minus 3, it will be 0. For x is equal to plus 3 also, the expression will be 0. So when x, so 9 minus x square, the range of 9 minus x square, 9 minus x square belongs to minus infinity to 9. 9 minus x square belongs to minus infinity to 9. But this function cannot take the negative value because square root of a negative number is an imaginary number. So the values for which 9 minus x square is positive should be taken, positive or 0. That means when 9 minus x square belongs to 0 to 9, then the function is defined. So 9 minus x square belongs to 0 to 9. So root over of 9 minus x square belongs to 0 to 3. Okay. So range of this function. The second question, range of the function is 0 to 3. Range of the function is 0 to 3. Is it clear? Then come to question number 3. F of x is equal to under root x square plus x plus 1. F of x is equal to under root x square plus x plus 1. F of x is equal to under root x square plus x plus 1. F of x is equal to under root x square plus x plus 1. What is the inside function? The inside, let it be g of x. Inside function is x square plus x plus 1. Right? It is a upward directed parabola. And the structure of x square plus x plus 1 is like this. Okay. The vertex point of this parabola is minus 1 by 4, 3 by 4. This is minus 1 by 4. So this is 3 by 4. So the expression takes the values x square plus x plus 1. Gives you the value from 3 by 4 to infinity. Okay. So for all these values, the function under root this is defined. Hence, range of the function root over of this expression, it will be 3 by root 2, root 3 by 2 to infinity. So range of the function is root 3 by 2 to infinity. Then come to the question number 4. F of x is equal to under root x square minus 5x plus 6. Ayush, good morning. f of x is equal to under root x square minus 5x plus 6, right? So you see x square minus 5x plus 6 is a upward directed parabola. And the range of x square minus 5x plus 6 is minus 1 by 4 to infinity. For minus 1 by 4 to 0, for minus 1 by 4 to 0, function will be undefined. Function is defined when the expression x square minus 5x plus 6 gives you the value 0 to infinity. Okay. And square root of 0 to infinity will be 0 to infinity. So range of the function is 0 to infinity. Range of the function is 0 to infinity. Range of the function is 0 to infinity. Did you understand? Hello? So let's move forward to the next question. Next question, no, next function. Okay. Then write down absolute value function. Absolute value function. Absolute value function. It is defined as y equals f of x equals to mod x. It is defined as y is equal to f of x is equal to mod x, where mod x is defined as where mod x is equal to x if x greater equal to 0 minus x if x less than 0, where mod x is equal to x if x greater equal to 0 minus x if x less than 0. Mod is known as absolute value. Okay. So mod of 5 minus 5. Minus 5 is a negative quantity. Mod of minus 5 will be minus of minus 5. Minus of minus 5 is 5. Mod of 2, it is a positive quantity. It will be 2. So absolute value is always positive. Mod of 0 is 0. Okay. So this function is redefined as x is equal to mod x is equal to x if x greater equal to 0 minus x if x less than 0. So domain of the function is R. Domain of the function is R. That means this function is defined for all real values, and the range of the function, that means set of functional values of the function, is equal to 0 to infinity. Absolute value can never be negative, hence its range is 0 to infinity. Then come to graph of the absolute value function. Y is equal to mod x. Graph of y is equal to mod x. So this function has two branches. One branch is y is equal to x, where x is greater or equal to 0. The second branch is y is equal to minus x if x is less than 0. Y is equal to x is a straight line passing through origin making an angle 45 degree with x axis. Y is equal to minus x is a line, straight line passing through the origin making an angle 135 degree with x axis. Okay. This is y is equal to x and this is y is equal to minus x. Clear? Y is equal to x, y is equal to minus x. Now come to properties of absolute value. Is it clear, guys? Let me know, is it clear? Why don't you write in the chat box, is it clear? JKBK, Bibu Prasad. Then come to properties of absolute value. Properties of absolute value. Property 1, mod x is equal to x if x greater than 0, mod x is equal to minus x if x less than 0 is the definition, right? The second one is mod x square is equal to x square. Mod of minus x is equal to mod x. X plus y mod less or equal to x mod plus y mod. X plus y mod less or equal to x mod plus of y mod. Write down equality holds good. Equality x plus or minus. Equality holds good when both x and y are of same sign or one of them is 0 and its equivalent mathematical expression is xy greater or equal to 0, right? Then fourth property, x into y mod equals x mod into y mod. X into y mod equals x mod into y mod. This implies x to the power n mod is equal to mod x to the power n. X to the power n mod is equal to mod x to the power n. Then property 6, x upon y mod equals x mod upon y mod. X upon y mod equals x mod upon y mod. Property 7, x mod less than k, where k is a positive real number, implies x belongs to open interval minus k to k. Eighth property, x mod less or equal to k implies x belongs to closed interval minus k to k. Property 9, x mod greater than k implies x belongs to minus infinity to minus k open union k to infinity. And the 10th one, x mod greater or equal to k implies x belongs to minus infinity to minus k closed union k closed infinity open. These properties you have to remember because while solving domain range questions, okay, you will need these properties. Done. Let's move forward to solve a couple of questions on domain. Question I done. Find the domain of the following functions. Find the domain of the following functions. Okay. 2 minus x upon x square minus 1 mod. Okay, these are the 5 questions. Try to solve these 5 questions and send me the answer. Oh. Okay, let's start solving the question number 1. F of x is equal to 1 upon under root mod x minus x. F of x is equal to 1 upon under root mod x minus x. The function to be defined under root expression should be greater than 0. So mod x minus x greater than 0. This implies mod x is greater than x, which is possible only when x belongs to r minus negative real number. So domain of the function is minus infinity to 0. Okay, this is the answer to question number 1. Then come to question number 2. F of x is equal to under root mod x minus 3. F of x is equal to under root mod x minus 3. Function to be defined under root expression should be greater or equal to 0. So mod x minus 3 greater or equal to 0. So mod x minus 3 greater or equal to 0. Just one property I have written down. Mod x greater or equal to k implies x belongs to minus infinity to minus k union k to infinity. So domain f is equal to minus infinity to minus k union k to infinity. Is it clear? Then come to question number 3. Now solve the inequality 4 minus 2x plus 3 upon 3x minus 1 mod greater or equal to 0. This implies 2x plus 3 upon 3x minus 1 mod less or equal to 4. So mod x less or equal to k implies x belongs to minus k to k. Minus 4 minus 4 less or equal to 2x plus 3 upon 3x minus 1 less or equal to 4. So there are two inequalities. One is left inequality and right is, and second one is right inequality. We'll solve these two inequalities and take the intersection of the two. Okay. So first solve the left inequality. 2x plus 3 upon 3x minus 1 is greater or equal to minus 4. This implies 2x plus 3 upon 3x minus 1 plus 4 is greater or equal to 0. So it is better to use another page. So guys, quickly note it down. I'll go to another page. 2x plus 3 upon 3x minus 1 plus 4 is greater equal to 0. Yes. This implies 2x plus 3 plus 12x minus 4 upon 3x minus 1 greater equal to 0. 14x minus 1 upon 3x minus 1 greater equal to 0. Critical points are 1 by 14 and 1 by 3 plus minus plus. So minus infinity to 1 by 14 union 1 by 3 to infinity. This is the answer to the left inequality. The right inequality is 2x plus 3 upon 3x minus 1 less or equal to 4. 2x plus 3 upon 3x minus 1 less or equal to 4. This implies 2x plus 3 upon 3x minus 1 minus 4 is less or equal to 0. This implies 2x plus 3 upon 3x minus, 7 minus 10x upon 3x minus 1 less or equal to 0. This implies 10x minus 7 upon 3x minus 1 greater or equal to 0. Critical points are 7 by 10. And this is 1 by 3. This is 7 by 10. Plus minus plus. Okay. Positive region. Minus infinity to 1 by 3. Union 7 by 10 to infinity. Okay, this is the answer to right inequality. Now we have to take the intersection of the two solutions. So to find the intersection of the two solutions, we have to mark all the critical points in one number line. 1 by 14, 1 by 3, then 7 by 10. 1 by 14, 1 by 3, 7 upon 10. Take the solution of the first inequality. Minus infinity to 1 by 14, union 1 by 3 to infinity. The second solution is minus infinity to 1 by 3, minus infinity to 1 by 3, union 7 by 10 to infinity. So what is the intersection region? Minus infinity to 1 by 14. Thus domain F is equal to minus infinity to 1 by 14 closed, union 7 by 10 to infinity. This is the answer to the question number 3. Quickly note it down. Okay. Kulpani Janta says JKBK Sikuri. Then come to question number 4. The question number 4 is f of x is equal to under root x square minus 5 mod x plus 6. Okay. So domain F is the set of all x such that x square minus 5 mod x. Hey, Manoj, आपसे चाह नहीं? नहीं. Okay. So x square minus 5 mod x plus 6 greater or equal to 0. So you know x square is equal to mod x square. So in place of x square you can write down mod x square minus 5 mod x plus 6 greater or equal to 0. If you consider mod x as y, then it will be y square minus 5y plus 6. If you factorize it, it will be y minus 2 into y minus 3. So directly you can write mod x minus 2 into mod x minus 3 greater or equal to 0. Mod x minus 2 into mod x minus 3 greater or equal to 0. So the critical points are 2 and 3 for mod x. Okay. Now find the region for mod x. So this is 2, this is 3, plus minus plus. That is mod, either mod x belongs to minus infinity to or mod x belongs to 3 to infinity. So if mod x belongs to minus infinity to true, we can say mod x less or equal to 2 or mod x greater or equal to 3. Mod x less or equal to 2 implies x belongs to closed interval minus 2 to 2. Mod x less or equal to 2 implies x belongs to closed interval minus 2 to 2. Mod x greater or equal to 3, x belongs to minus infinity to minus 3 union 3 to infinity. X belongs to minus infinity to minus 3 union 3 to infinity. Okay. So union of all these three will be, so domain of the function is, thus domain of the function is minus infinity to minus 3. Okay. Union minus 2 to 2 union 3 to infinity. Minus infinity to minus, this is the required domain of the function. So guys, quickly note it down. Then come to the last question. Two minus x upon x square minus mod. F of x is equal to under root 2 minus x upon x square minus 1 mod. Okay. Come to the solution. Domain F is the set of all x such that under root expression should be greater or equal to 0. 2 minus x upon x square minus 1 mod should be greater or equal to 0, right? This implies 2 minus x upon x square minus 1 mod greater or equal to 0. This implies x upon x square minus 1 mod less or equal to 2. This implies minus 2 less or equal to x upon x square minus 1 less or equal to 2. Here two inequalities are there. One is left inequality, another one is right inequality. The left inequality is x upon x square minus 1 greater or equal to minus 2 and x upon x square minus 1 less or equal to 2. X upon x square minus 1 greater or equal to minus 2 and x upon x square minus 1 less or equal to 2. How did you by way? How? X upon x square minus 1 greater or equal to minus 2 and x upon x square minus 1 less or equal to 2. X upon x square minus 1 greater or equal to minus 2 and x upon x square minus 1 less or equal to 2. Okay. We'll solve these two inequalities separately and then we have to take the intersection, right? Already I've done a question like this. So x upon x square minus 1 plus 2 is greater or equal to 0 and x upon x square minus 1 minus 2 is less or equal to 0. Got it? So this implies x plus 2x square minus 2 upon x square minus 1 greater or equal to 0 and x minus 2x square plus 2 upon x square minus 1 less or equal to 0. So this implies 2x square plus x minus 2 upon x square minus 1 greater or equal to 0 and to solve the inequality we have to make the leading coefficient positive, for which we have to multiply the expression by negative 1. So it will be 2x square minus x minus 2 upon x square minus 1 greater or equal to 0, right? So what are the roots of the equation? 2x square plus x minus 2 greater is equal to 0, square minus 4ac. Okay, minus 1 plus or minus root 17 by 4. So upon x plus 1 into x minus 1 greater or equal to 0. Okay, can make space here. So critical points are minus 1, 1, minus 1 minus root 17 by 4, minus 1 plus root 17 by 4. Okay. The critical points are -1 minus root 17 upon 4, then -1, then -1 plus root 17 by 4, then 1. Sign scheme is plus minus plus minus plus. Which region is required? Positive region. So the positive region and 0. This is included. Then -1 excluded. Then this is included. Then this is excluded to infinity. Okay, this is the solution to the first one. Then we will solve the second inequality. The right hand side inequality 2x square minus x minus 2 upon x square minus 1 greater or equal to 0. And so this is 2 into x minus 1 minus root 17 by 4 into x minus 1 plus root 17 by 4 upon x plus 1 into x minus 1 greater or equal to 0. Right? The critical points are 1 minus 1, 1 minus root 17 upon 4, then 1 plus root 17 by 4 plus minus plus positive region Okay, I hope it is clear to you. Now you have to take the intersection of these two. Okay guys, your session is over. So rest of the things rest of function will be discussed in the next session. Okay.